So hello everyone, welcome in this video tutorial on Java generics. So as you can see this particular sign, this sign is a sign of the Java generics. We have this particular sign over here, this less than sign and greater than sign, and whatever we pass inside there, that is considered as a parameter. So this parameterized type is known as the Java generics. So what is Java generics basically? It's a parameterized type. So what do you mean by this parameterized type? It is like to create a general parameter which can take any kind of the data type. So we can have the parameterized, you have seen about the methods, right? Java methods where we can pass parameter of integer type, float type, or object type, or particular class or interface type, right? But what if we don't provide any data type over there, like integer or float or character? We don't want to provide anything, or class or interface. We don't want to provide any particular data type in the parameter. Rather, we just make it general. So there from the term generics has come. We can provide a parameter without providing any particular data type. Yes, to where? To method also you can provide, to classes also you can provide, and interfaces also you can provide. Yes, so it will work with different data types if we create the parameterized type that is known as the generics. How it's possible? How it's possible that you can pass a particular parameter to a class or interface or method without providing any data type that you have not seen before, right? Yes, that can be obtained by using Java generics. Yes, so how this generics is defined basically, we'll see in this particular Java program. See, this class test is given like any other class space test. After that, what we have provided is specifying the generics. That is, this particular class test can take one parameterized type. The name of the parameterized type is given as T. So T can be passed as what? Integer or float or double or even an object, because T can be any. It can be int, it can be float, it can be any. Let's check how it works actually. So this T is a type. It's like integer. We have integer type, float type, object type, right? T is a type. We have defined like that. How we are defining that? We are creating an object reference. Yes, so this reference is named as obj. It's of the type T. See, the new type you have created. It's possible. And now next line we have provided the constructor. This is the constructor of the class test. It takes an argument. What argument it takes? One reference of the type T. Yes, so you are seeing that one constructor even can take not only integer, float, double, or any other primitive or non-primitive data type. It also can take as an argument one object of a generic type. What's the generic type here? The generic type named here is as T, and the name of the variable we are passing is the reference variable of the type generic T, correct? And that particular generic is assigned with this particular generic value. So whatever you are passing in the constructor as an argument, that will be assigned to this obj, and it will refer to the current object. That's why you are giving this dot obj. Okay, now we have a method over here. That method, now you are seeing that one method is there, get object. Now you are seeing that this object method even can return a type of the generic T. So generic type T is returned by this object. By using the return statement inside the method body, you can see we are returning out the value of object which has been assigned here. So object is assigned by using this constructor, and this object is returned for the current object, for the current instance which is calling this particular method, and it is returned by this method get object. So get object will give you back this particular object reference, correct? So we have understood that a generic class is created. Inside the generic class we have used the generic constructor by passing the generic value, and we have used a method which also returns the generic value, correct? Now we'll see how this thing has been called. See this now, how this thing is used now. From the main class we have written public static void main, and from there what we are doing, we are created one instance of integer type. How it is an integer type? Because we are specifying this particular thing. So this class test can take any type of the parameterized type, anything. It now T can represent integer, T can string, T can represent string or any other instance, any other type, right? Because integer is an object. It's a class, right? Integer. So IOBJ is an integer type object only. Integer is a by default built-in Java class. Similarly, string, character, boolean, byte, long, all are the wrapper classes defined by Java compiler, correct? So we are providing over here that you are creating one test T. So if you don't write down this line, then that will be giving error. See this line started giving error because we have not created generic class. So we first have to create the generic class. Now we can create generic types. What type you have created now? A specific type of integer we have created. Are you clear? Now this is the object IOBG is created for that particular integer type with the value 15. So how to create? In this way we have to create test, then this generic type T is holding the value integer, then the object is created. We have used the new keyword, then test. Again you have to specify in the same way that you're going to create the object of the type of the class test which has the generic parameter integer. Now we have defined this with the integer. We can give any other value also, and value is 15. So IOBJ has having the value 15 now. Now if we call IOBJ object to call the get object method, then what will happen? See this, whenever this 15 is, when this line will be executed, the single parameterized constructor will be called, right? So line number 19 which fetch will call the line number 9, and then obj will hold the value of 15 now. See this, we are passing integer, but this is considered as the generic type T, and this obj is equals to 15 is assigned to this value. So T, this one has got the value how much? It has the got 15 right now. In the next line, when you are calling this get object, it will call line number 10 over here, and it will return what? It will return 15. Correct? So it should supposed to print in the output screen what? 15. I'll run later. First let me explain. Next instance of string type is created. See this, just you have changed here string, that's it. Now this class can take string argument. How? We are passing generics in Java introduction. So this line will also call line number 23, will also call line number 9 over here, and it will assign this obj as generics in Java. This string will be taken as this obj. Now last time it has taken the same constructor, last time taken integer value, now it can take the string value, and that string value will be assigned to this particular object, correct? And the value will be how much? Now it will be assigned to this particular string. So right now it's not assigning 15 unlike the last time. Now it is referring to generics in Java introduction. Now that is being assigned over here. Yes, and that is being returned from this next line method calling get object. So it will return what? Generics in Java introduction. So if we call this method, what will happen? It will print 15 first, and then this particular string in the next line. So in this way, one particular class can be used to pass arguments of the different types. So if you don't use generics, then what you have to do? You have to specify here first time one constructor with the value integer. Another time you have to write down another constructor with the constructor overloading idea. Correct? And you have to provide over there string argument. And you have to create two different methods. One method to return the integer type and variable. Another method you have to write down to return the string type data types. Correct? Yes, so you have to use the concept of constructor overloading and method overloading. So your code will be larger. So in this way, you are syncing your code, you are smalling and you are compressing your code, and you are making your program efficient. That's the benefit of using this particular concept of generics. I hope that you have understood this. Now we'll deep dive. We'll go inside the different programs of this particular concept, generics. Now we see a next program. We can also pass multiple type parameters in generic class. Last time we just provided a single argument. Yes, either integer or string or any other data type you can pass on the last program. In this particular program, we use the multiple type parameters in Java generics. See here, let's start. So these programs are written in front of you, and all the programs you will get from this particular PDF. So guys, it will be easier for you to understand. You just download it from the description of the video and you can get this entire note, and with all the programs are there over here. Yes, why generics are used, this thing I have not explained. See, the object is the superclass of all the classes, right? Java.lang.object is a class which comes with the java.lang default package, which is included to each and every Java program by the compiler. That has a class named object class. That's the superclass of all classes. So object reference can refer to any type of object. Yes, this feature lack the type safety. The type safety feature is added by where? Generics. Yes, that thing we'll see over here one by one. So we'll go to this program. This program, see that this particular class test can hold two different parameter. First parameter is of the type T and other parameter is of the type U. So we have to create the object reference of T and U, and then see this constructor now takes two generic parameter. First parameter is obj1, next generic parameter is obj2. So obj1 may be integer, float, double, or any primitive or non-primitive data types, and obj2 can also be any primitive or non-primitive data types. And this print method is printing these values obj1 and obj2, which has been assigned by this constructor. Yes, now we are creating the main method over here, and in this particular class we have designed as string and integer. See, the first argument we are taking as string, and the next argument we are taking as integer. So first one is string over here and next one is integer. The way we created the object, this time also we are creating the object, but we are just using two different parameters, and first parameter value is hello generics and 15. So line number 61 will call line number 42, and these objects will be assigned. This is the string which you are passing. What's that? Hello generics. Next one you are passing 50. So hello generics will be assigned with the object 1, and the object 2 will get 15 value, and that's being printed over here, correct, by using the print method calling. See this printing hello generics and 15. Yes, you can even alter it by any way. No need to change any code on the class test tu. In this test class, definition need not to change because it's a generic class. It has defined that. You can just alter that. You can keep integer, string, or any other alternative you can do. Based on that, you just pass the value and that will be printed very easily. So that's the benefit of using what? Generic classes. Now we'll see that a simple Java program to show working of user defined generic functions. So how can we define our own generic functions? We'll see over here. See, this class main is given. In this particular class, we can see that one method we have defined is all of different method. What's the method it is? It is generic display method, which takes an argument of the generic type T. It returns void and generic type T. Are you clear? Now, what we are passing over here in the system.out.println, what you are going to print, whatever the element you are passing as an argument while calling the generic display method, that elements get class.getName. So these two are the get class and get names are methods which are available in the lang class, right? It's in java.lang package. These methods are by default available, and it will get the name of that particular class based on where the element is being belongs to, and the element's actual value we are printing over here by giving a equals to sign. So it will give the particular element. Suppose the element you are passing is of type int. So integers belongs to the wrapper class integer. So it will display integer class. Similarly, string will display string, character will display character, float will display float class. All the wrapper classes we have, those things will be displayed. Yes, that's it. That's what the funda is over here, and it's a static method. We can call it directly. So see, from the main method, what we are doing. From the main method, we are directly calling. No need to create the object of the class because it's a static method and it's inside the same class. So you can call generic display, then pass the value 11. So when you're passing the value 11, it will be displaying 11. Along with that, it will get the name of the class where this value 11 is converted to. Keep one thing is fine. In generic, no, it's a generic. T is generic parameter, right? So for generic parameter, the compiler will convert this 11 to the integer type because it knows this is an integer argument. There is a string argument you are passing, and there is a double argument you are passing. So it will be giving that particular class name which has been taken by the compiler. See this, where it belongs to java.lang.integer. I told you these wrapper classes are there, and these two methods are also available in java.lang package, and it will give you back the particular wrapper class name, which is the holder which will box this particular value. This is the integer value, right? It will be boxed to this wrapper class, auto boxing. So this string is auto boxing to this particular string value, and this 1.0 is auto boxing to this double value. So that particular class name is being displayed, and these are the particular values are displaying. So in this way we can see that one particular function can hold. This is the user defined general function which can take any argument as as argument of this particular method. Now we'll see working of user defined generic classes. So no need to display this example. This example is already shown. So just for your basic understanding, check it out. Here you have given the 15, and here you have given the same string argument passing is exactly like the last program. This part of this code is exactly like the first program which I displayed to you. There is no difference between the first program and this. But here I just want to show you one new thing. If you are assigning that IOBJ to this object, then what will happen? Although both are the object of the same class, right? Test class. But you cannot assign the object of one, the same class object, that is the one object to the another object. Here we are assigning this object value to this object. It's not possible. Why? This is because this string type object has become, because we have used the string parameter, and this class is use the generic terminology, and it has been provided this particular integer values. So integer value has been provided over here. So integer values cannot hold the string values. So integer object containing IOBJ can only hold integer object containing value only. So if you create something else over here, let's see, then what will happen. Let it be integer. The object name is obj IOBJ1, correct? And if you assign IOBJ1, let me just save it. See this, now the error is not displaying. Why? Because this is also integer type passing, and here also you are passing integer type, maybe any other value, but it's possible. But if you want to assign that to this particular string object generating, string object generating, right? We are generating a string value now, so it cannot hold this particular object. It will be giving an error. So this example to show that minor thing only. Now we'll see that if you, one of the benefit of using generics is that if you don't use generics, sometimes the compiler will not recognize the program as error, but during runtime you will get difficulty. So we'll give this particular example here. See this, what you can see in this particular example. In this particular example, you can see this main class is there, their public static void main method is there, and we have a array list object. The name of the array list object is what? A1, correct? Now this array list object is not a generic one, so it can hold any value, right? So when you are writing a1.add Sachin, a1.add Rahul, so these values are one by one being added to the array list. So a1 at the location at the index 0 hold the value Sachin, a1 at the location 1 holds the value Rahul, a1 at the location 2, it's like an array location 0 1 2 3 4 5, in this way it will go. In the array location 2 it will hold the value 10. But compiler will allow this, right? Yes, because we have not specified any type over here. We have not told that it's an integer or it's a string. Yes, there is no generic type you have provided over here. So the compiler will let to get in any value over here. Yes, correct. But when we are getting this value, it will be giving, it will get 0 means in the 0th location, whatever the values are there in the object A1, fetch it, convert to the string, and then print it to the S1 and store it to the variable S1. That's fine. Now whatever the value is in the location 1, what is the in the index 1, what is the value in the index 1 for AI? That is Rahul. That will be fetched, it will be converted to string again, and it will be stored where? In the string variable S2. It's all fine. Now what is there in, so here what you are getting, here you are fetching the value Sachin in the index 0. Here we are getting and fetching the object Rahul, correct? Similarly from here we are getting the object 10 in the location in the index 2 of the array A1, correct? In the array list is like that only. It will create the list of the values as per an array, as the name implies. So now it is converted to string, and in giving into S3, it's also the compiler will allow this particular statement. But when you run this program, you can see that the Java compiler won't allow that. See this java.lang.integer, it's an integer, right? Cannot be cast into java.lang.string at main method. In the main thread, they are giving the display. So this here, this particular integer value cannot be converted to this particular string value. So it cannot store in this particular string variable also. That's what the Java compiler is telling during runtime. So this kind of program is very difficult to sort out, right? In the compiler time, because in compiler will not give any error. So compile time you cannot deal with that. What's the solution? Use generic. That's the advantage of using generics. Now we'll see that smart use of generics will provide all the problems out. Here the compiler will tell now that you are doing something wrong, because you have just commented this line and opened this particular line. What you have done, we are telling the compiler that it's a string. This array list is of the generic type string. We cannot allow non-string things here. So here we are specifying that it's the string, correct? So this A1 object, at least the A1 object can hold only string values. So how can you add an integer values to a string type of object? This object A1 of the type of the class array list, which belongs to the java.util package, can only hold string values. So integer will not be allowed. So here in the compile time only, the compiler is giving the error. See, it is asking that during compile time only error is there. Similarly, we can create an object, another object of the type integer. You can give integer, right? If you give it integer, then what will happen? This one will now take, now this object A2 can only take integer values. So if you give right now with the Sachin, it will also give error. See, it is telling that A2 can hold only integer values. You can only pass integer values in the add. You cannot add into the array list A2. You cannot add any other value. So if you give 19, it's all okay. If you give A2 dot add is a array list method which adds elements to this particular array list. It's a by default available method, okay? So if you add 10, then there is no error right now. Rather, if you want to print these values of this particular S1, S2, S3 by using system.out.println, right now each and everything will work. So please check as an assignment, take it as an assignment, execute this particular program. Yes, still now it's giving the error. S3. Well, so this particular program take as an argument and execute that. See, now there is no error is giving. So if you print S1, S2, it will be printed properly. So take it as an assignment, okay? Check it out. Just change this, generic types and see that how the things are working for you. Now we'll go to the next and last program. I just want to make all my video within half an hour of duration, but it generally gets out of it because I want to teach you with all details. I don't want to skip and just want to teach you the theoretical parts. I just want to show you with the practical parts as well. So that's taking more time to explain each and everything bit by bit. So now we'll see this particular program, the last program. So this is another advantage of using generics. I'm showing you the advantage of using generics in the last program also, in this program also. We no need to typecast individual member of an array list. That's the benefit of using. Yes, generics is having that use also. We no need to typecast each and everything. See here we have array list object of type string. A1 can hold only string values. Correct. Now last time you have done the typecasting over here, na? Now as if you're telling it that if you use this particular statement in the last program, that if you don't specify that is string type of object of array list, then you require to typecast. In this way we did, na? Otherwise it will give error. But if you specify it in this way that it's the string type of object only, A1 is an object of the class array list which is available built in java.util package, and the name of the object is A1. Right now A1 can hold, you can add any number of elements by using the built-in method add to A1, correct? Now to get this you have to call the get method and you have to pass the index where this particular strings are available, correct? But there is no need to typecasting by using this. Explicit typecasting is not required. This is not required for both of the lines. See, this thing we can do it, but it's not required. If you run, you will get the output, right? Because you are printing S1 and S2. You'll get the values Sachin and Rahul. But if you don't write and execute, see this now, the same result is being shown over here also. Why? The reason is that there is no requirement of typecasting if you are providing the generic type over here, because by default it can hold all the string values, so it knows that it can fetch only string, not non-string values cannot be stored in this particular array list. So how can you derive non-string values from there? So anyhow it cannot be possible. So S1 and S2 will be always giving what? The string values only. So there is no need of typecasting. So that's the advantage of this particular concept. So whatever things I have explained over here or whatever things are provided in this particular PDF, all has been explained to you. Yes, so and this PDF I'll provide into the description section of this particular YouTube video. So please download from there. If you like the way I'm teach, and if you weigh the if it adds value to your Java learning experience, then please subscribe to my channel. Thank you.